Yo, what's up, ladies and gentlemen, and welcome to a new video. There we got a two-way program in Python, you know what I'm saying, that represents signed integers using three methods: the first complement, the second complement, and signed bit method, you know what I'm saying, bro? So, of course, we are using once again the prompt toolkit library, you know what I'm saying. It's easy to install using the pip install command, pip install prompt toolkit. Also, make sure to take a look, drop by this documentations of the prompt toolkit library, you know what I'm saying. It's gonna help you a lot to achieve what you're trying to achieve, you know what I'm saying, bro. Anyways, let's take a look at the program. Of course, so how it works: number one, you choose the method; number two, you type a value; number three, you observe the result. You know what I'm saying? Simple as that. Signed integers representation using three methods: signed bit, first complement, second complement. Now let's press exit. Of course, it exits. You know what I'm saying? It's the same as the 16-base converter. Okay. Now you pick an option: signed bit to decimals, decimal to signed bit, first complement to decimals, decimal to first complement, second complement to decimal, and decimal to second complement. We're gonna test all of these. Now let's begin with the signed bit to decimal, you know what I'm saying? Okay, so we know about signed bits that the most significant bit is 1 or 0. I already made some videos, 2 videos, explaining how this code, like the C code, of how we convert from first complement to decimal, and from decimal to first complement, and from decimal to second complement, and how to do the signed bit representation. Now, once again, it's just a matter of converting the C code to Python, you know what I'm saying? So it's a simple task. Now, please type a binary value. Let's try, for example, 1, then 1, then 0, then 1, then 0. This one is definitely minus 10, you know what I'm saying? And boom, value is minus 10. Now let's do a 10, you know what I'm saying? 0 for positive, you know what I'm saying? Not minus 10, but 10, and 1, 0, 1, 0. Boom, value is 10, you know what I'm saying? Now, let's test decimal to signed bit. For example, let's do a 10. Number of bits 5, and boom, 0, 1, 10, 10. Now let's do a minus 10. Number of bits it's 5, and 1, 1, 10. I'm saying it works. This time another number, for example 36. Number of bits is 16, and boom, this is the answer. I don't know, verify that yourself, you know what I'm saying? Now let's move to the second method, which is the first complement. Now let's do the first complement to the what do we call it, the decimal, which is 110, 110, which is first minus 5. Yes. Let's do, for example, first complement to decimal. Let's do 0, 1, 0, 1, and let's see what's that. It is a 10, you know what I'm saying? Because it's not negative. Now let's do decimal to first complement. Let's type minus 5. Number of bits is 5, and boom, yes. Is this minus 5? Yes, I believe it's automatic extension of ones, because it's negative, you know what I'm saying? Like, for example, let's do minus 5. Let's do minus 5, but with 4 bits, you know what I'm saying? Which will give us 10, 10, you know what I'm saying? Because it's the 10, and it's using the famous, like, 2 to the power of n minus 1 plus the negative number. Now let's try a second complement. It must give us, let's try 1, 1, 1. This is probably definitely minus 5. Yes. Boom, let's go. Now let's try decimal to second complement, which is minus 5. It must give us 11, I believe 10, 11. And number of bits is 4. Yes, it's working. Now let's try the input from the user, and let's try some other values. For example, let's go to the decimal to first complement and some characters. Boom. Input value is not an integer. Now let's type, for example, a 10, and let's choose a number of bits, a small number of bits, for example 1, and boom, number of bits ain't sufficient. Let's choose 9. Boom, it's working. You know what I'm saying? Let's go. Now let's try again with decimal to second complement, and let's type a number, for example 10, and number, let's type not, keep it. And boom, you know what I'm saying? Like, if you don't type nothing, you know what I'm saying? If you type nothing, it will just loop over to the same dialog page, like interface. So I guess anyways, I believe this is the code. If you wanna take a look at it, I'm gonna leave it in the comment section. So basically we have a binary number. This one gives us the input of the one and zeros, where this one is input of numbers, It does a check for negative numbers, like this one right here. Like, pay attention to this one. This was a pain in the ass, like, like how to fetch for the string negative numbers only. I do a check for all the other stuff. Also, these two lines over here, if text is none, you exit from the code. Like, I believe this one is for cancel button or like exit button, I believe that's it. And also over here we have the return in text. We have bits. For example, if also in the functions of that converts, like represents the numbers into binary, remember to do this, add equals the function of bits. Don't use return bits, like only bits, because the value of the base, like of the number of bits, will be lost on the stack of the functions. Like, that's how I understood it, bro? And also, I believe that's it. Yes, that's it. It's working hella fine, man, Also, we have here some styles, you can change the colors and everything, and get an input. Simple as that, man. Anyway, thank you for watching, and I'll catch you in the next one.